This class we focus on how a boolean function is represented, how many boolean functions are possible, and what will be the various constraint, etc. If n boolean variables are given, a boolean variable is the one which can take either 0 or 1, then 2 to the power of n boolean functions are possible. That means if n is 2, then 2 power n, which is nothing but 2 power 4, 16 boolean functions are possible. We would like to see what are that 16 boolean functions. Two variables will have 4 slots, 0 0, 0 1, 1 0, 1 1, and each slot can be independently assigned with either 0 or 1. So what are the various assignments? 16 assignments are possible for these 4 slots, and each assignment is one function. This is f0, f1, f2, f3, f4, like that f15. If all of them are 0, we call such a function as null function. Irrespective of the input combination, output is 0, what we call that function? Null function. Permanently 0. And obviously all of them are max terms. And a function here, it is one single one is there, and one main term and 3 max terms. So better to write in SOP form. The SOP form expression is AB. So this column is talking about the boolean function AB. When both inputs are 1, it is 1. Now it is also having only one main term, that is at A is 1 and B is 0 row. Hence what is this expression? A B prime. And F3 is having two ones. One is at 1 0 input combination, another is at 1 1. If you observe that, it is 0 0 1 1. F3 is also 0 0 1 1, and hence F3 is simply saying that A. And F4, only one main term is present at 0 1 column, hence its expression is A prime B, only one place. And F5 is having two ones, 0 1 0 1. It is for 0 0. F5 is 0 for 0 1 of AB. F5 is 1 1 0 of AB. F5 is 0 1 1 of AB. F5 is 1. If you observe a little carefully, it is 0 1 0 1. F5 is also 0 1 0 1. We call this as B. And F6, 0 0. F6 is 0 0 1. F6 is 1 1 0. F6 is 1 1 1. F6 is 0. Obviously it is having two min terms and two max terms. Whenever the inputs are different, output is 1. It is A XOR with B. And F7, it is having one max term and three main terms. One max term and three main terms. So what is the max term expression here? A plus B. So F7 is OR operation. If I write, F0 is null, F1 is AB prime, F2 is A, and F3 is F2 is AB, F3 F1 is AB, F2 is AB prime, F3 is A, F4 is A prime B. People call it as A implies B. F5 is B, F6 A XOR with B, and F7 is A plus B. And from here onwards, all of them are complements of each other. F7 is the complement of F8, or F8 is the complement of F7. So it is going to be OR complement, which is nothing but NOR. And F9 is going to be the complement of F6 XNOR. F10 is the complement of F5, which is nothing but B prime. F11 is the complement of F4, which is nothing but A plus B prime. F12 is the complement of F3, that is A prime. And F13 is the complement of F2, which is nothing but A prime plus B. And F4 is the complement of F1, which is nothing but NAND. We can write it as A prime plus B prime, only one max term. And F15 is tautology. We call it as complement of null. So 16 Boolean functions are possible with 2 Boolean variables. Now we will have several representation of these 16 functions. One of them happens to be the permutational approach. So it is something like tossing the coin 4 times. So total number of outcomes are 2 power 4, 16 outcomes are 2 power 1 minute. 4 times you are tossing, the number of outcomes are 2 power 4, 16 functions are possible. So when you toss it, there is a possibility of head or tail. So 4 times you are tossing and there is no head, a single head, 2 heads, like that we can say 3 heads, all 4 heads are possible. Or what we can say, 0 main terms, 4C0, 4C1, 1 main term, 4C2, 2 main terms, 4C3, 3 main terms, 4C4, all 4 main terms are there. So the number of Boolean expressions that contain only one main term. This is the number of Boolean expressions that contain 2 main terms, 3 main terms, 4 main terms. We can write this as 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4, which is obviously 2 to the power of 4. That is nothing but 16. Since NCR equal to NCN minus R, we can write 4C1 can be written as 4C3. And 4C0 can be written as 4C4. Hence twice of 4C0 plus twice of 4C1 plus 4C2. So twice of 4C0 is 1, twice of 4C1, 2 into 4 is 8, and 4C2 is obviously 6. So total number of functions are going to be 2 plus 8 plus 6. Hence it is going to be 16. This is how you can represent a Boolean function. This is having an important conclusion, and in many competitive examination they can ask the question, how many Boolean functions are possible? With 3 Boolean variables, such that they contain either 3 main terms or 4 main terms. So total, since there are three boolean variables, the number of rows are going to be 2 power 3, and each row can be independently assigned either 0 or 1. Hence 2 power 3 possibilities are there. 8 possibilities independently we can assign either 0 or 1. And hence he is asking how many functions are possible either with 3 main terms or 4 main terms. 8c3, 8c4. This can be written as 8 factorial into 7 into 6 into 5. Like that we can write it. So 8 factorial divided by 3 factorial into 5 factorial. So which is going to be 8 into 7 into 6 by 3 into 2, 56. And here 8 into 7 into 6 into 5 divided by 4 into 3 into 2. So this is going to be 70, hence 56. This is going to be 70. Total functions are going to be 126 functions are possible. If there is no restriction, then the total number of boolean functions are going to be 2 power 2 power 3, that is 2 power 8. 256 functions are possible without constraint. So here the constraint is given. The constraint is either 3 main terms or 4 main terms. Hence it should be 8c3 plus 8c4. Suppose he says at most three main terms. Then our answer is going to be 8c0, 8c1, 8c2, 8c3. At most means maximum. Then it is going to be 1 plus 8 plus, this is 8 into 7 divided by 2, this is 8 into 7 into 6 divided by 3 into 2. So total is going to be 1 plus 8 plus 28 plus 56. This many are possible. Oh, if you add it, then it's going to be given 36 plus 1, 37, 37 plus 6, 43 plus 50, 93 are possible. So like that we can add it, then it is going to produce what will be the number of boolean functions that are possible with 3 boolean variables. Suppose he says exactly 5 main terms, then answer is going to be 8c5, that is 8 into 7 into 6 divided by 5 into 4 into 3 into 2, which is equal to, okay, if I want to write, we can write it 8c, say 8 into 7 into 6 is divided by 3 into 2, it is nothing but 8c3. So 56 boolean functions are possible. So what will be the total? I say 8c0 plus 8c1 plus 8c2 plus 8c3 plus 8c4 plus 8c5 plus 8c6 plus 8c7 plus 8c8, all put together 2 power 8, 256 Boolean functions are possible. This is how you can represent a Boolean function using the permutation aspect. The next one is binary tree approach. So we can represent a Boolean function with the help of a binary tree, and so here it is a 3 variable function. So a can be 0 or a can be 1. So 2 branches are there from a root. Again from the root b, 2 branches are there. A, b is 0 and b is 1. Again from this branch c, there are 2 functions. C is 0, c is 1. So like that, we are able to construct a binary tree for a given Boolean function. And here the hashed value is going to be 1, output is 1. So there are 4 main terms are present, and this main term is a0, b0, c1, 0, 0, 1. The next one is a0, b0, a0, b1, c0, that is 0, 1, 0. And the next one is A1, B0, C1, and the next one is A1, B1, C1. So there are 4 main terms are there: 0, 0, 1, 0, 0, 1, and next one is 0, 1, 0, 0, 1, 0. Next one is 1, 0, 1, 1, 0, 1, and next one is 1, 1, 1, 1, 1, 1. Hence 4 main terms are there for this 3 variable Boolean expression. They are going to be sigma 1, 2, 5, 7. This is how you can represent, and these leaves can be assigned with either 0 or 1, since there are 8 leaves are there, 2 to the power of 8 ways of assignment. Each way is representing one Boolean function. If all 7 slots are 0, the last slot is 1, it is ABC. If the first slot is 0, all the 7 slots are 1, it is A plus B plus C. So like that we can have 256 Boolean functions are possible. Another one is a Venn diagram representation. 3 intersecting Venn circles can be drawn for 3 variables. So total 8. Regions are possible. The expression for each region can be represented as a product. So this is belongs to the A, does not belongs to B and C. How to write a product? A, B prime, C prime. This particular region belongs to A but does not belongs to B and C. Similarly, this region is belongs to B but does not belongs to A or C. Hence expression is A prime B C prime. And this region belongs to C but does not belongs to A and B. Hence expression is A B prime C C. And this outer region is neither belongs to A B C. Hence A prime B prime C prime. And the shaded region is going to represent a Boolean function. There are 4 zones are shaded. One is A, B, C prime. So Boolean function is representing by shading the Venn regions. One is A, B, C prime. Next is A, B prime C. This is the region shaded. Next is A prime B, C. This region is shaded. And finally, ABC, this region is shaded. Hence, it is denoting a Boolean function with four main terms. They are going to be ABC prime is 110, AB prime C is 101, A prime BC is 011, ABC is 111. Hence, it is going to be 3. This is 5, this is 6 and 7 sigma 3567 or pi of 0, 1, 2, 4. So this is how we can represent a Boolean function with the help of Venn diagram. We have seen a permutation aspect, we have seen a binary tree aspect, and the another approach happens to be Venn diagram. Finally, we can represent a Boolean function with the help of contact network. And the contact network is having serial contacts and parallel contacts. The serial contacts are representing, serial path is representing AND operation and parallel path is representing OR operation. A path starts from input and reach the output. Each path is a product in sum of product expression. A path is valid if and only if it is not having same literal both complement and uncomplement form, that as such as A into A prime is 0, it cannot be a valid product. So what we conclude, in a path there should not be the same variable both primed and unprimed form. For example, he has given this is the contact network and these are the variables are denoted. Now I want to know what is the expression represented by this 4 variable contact network. So one path is starting with A prime, passing through B and passing through D. Hence it is A prime BD. Another path is A prime passing through C, passing through D. Hence it is A prime CD. And another path is passing through B prime and D prime. This is B prime, D prime. Or simply we can say this is one serial path performing AND operation A and with dash D. And what was this? It is a serial path which will perform OR operation. So it is A prime and with B plus C into D. And this entire thing is again a parallel path. This is one path, this is another path, hence this is plus, and this is a serial path. What is that series path telling? B prime, D prime. So expression is A prime into B plus C into D plus B prime, D prime. So expression is expanded A prime BD, A prime CD and B prime, D prime. This is how you can represent a Boolean function with the help of contact circuit. So for example, it was given like this. This is A, this is B prime, this is C. So what will be the expression it is representing? A into B prime plus C, obviously AB prime plus AC. So like that, we are able to write a sum of product expression for a contact network.